Hey, hi, hello guys, welcome back to Code with Nani channel. So today we're going to discuss about the lead code problem of the day. Construct smallest number from di string. So you are given zeroth index string pattern of length n consisting of characters. I means increasing, d means decreasing. So if pattern of I is equal to I, which means this next element should next element should be greater than the previous element. If it is decreasing, then for previous element should be greater than the next element. Suppose we'll give an example: I d. Okay, so and we need to return the lexicographically smallest possible string num that meet the conditions. So so it means the string what is meaning of the lexicographically smallest. Suppose if you have a string 1234 and if you have a string 1230, so which will be the lexicographically smallest. We don't check the numbers using their value. In the strings we'll check the number as it is one on one, then as until 1 2 3 both are equal, then you'll check which is greater than element. So it is greater, so this will be the highest number, this will be the smallest number. Suppose we have another string 1 2 3 4 and we have a string 2, just 2. So what will be the bigger number according to the string? So this will be the bigger number because we'll compare the first letter. It is 1 and it is 2. So 1 is smaller than 2, right? So in that case, so 1, 2, 3, 4 will be the smallest lexicographical number. In the strings, we don't go with the value. Um, uh, we just go with the lexicographically order, which means this 1 is smaller than 2, right? So we'll check the places of the strings, then we'll compare it. So yeah, and we discuss like how do we solve this kind of problem. So you get to know about this lexicographically smallest possible number, and I will explain you like how do we get approach. So so it is a increasing element. So if we take one here, then increasing means then you have to take two. Increasing means you have to take three. Suppose in this case, if you take four, so if you check this d, which means the number should be decreasing, right? If you take five here, it is increasing. So we shouldn't take this way. Instead, you can take five here, four here. So if you see one, two, three, five. So one, two, three, five. So three number increasing, this is also increasing, 3 to 5 is also increasing, and 5 to 4 decreasing. So if you carefully observe, we have 3 increasing and 1 decreasing. So that's how we generally do. So, and another case will be another example. Suppose we have a d. So how do we do? We don't come from 1 to 3. So if you see, it is increasing, it is also increasing. And if you take 4, it is also increasing. So in that case, we'll just come out of from the backwards. 4 3 2 1. See, this is decreasing, this is decreasing. Why do we only start with 4? Why not we start with the 9? You can start with 9, you can start with 8, you can start with any 7, you can start number anything between 1 to 9. But if you carefully observe, we cannot place 1 here. So if you place 1 and the next element has to be decreased, so we cannot decrease less than 1 because always the number should be from 1 to 9, right? As it is a decreasing element, we cannot place 1 here. If you place 1 here, then the next element should be less than 1, which is 0. We cannot plus 0, right? So for that case, the minimum possible number that should be kept in the first digit is 4. Or else if you take a 3, you can keep 2 so that it be a decreasing, and you can keep a 1 that is will be decreasing, and still one more decreasing element is left, so we cannot place 0. So in that case as well, we cannot uh, get a formal string that gives output 3 decreasing. So instead we should start from 4 so to get the lexicographical smallest substring. So how do we approach this problem? How do we approach? So we can use monotonically stack. So what is monotonically stack? You can use monotonically increasing stack or decreasing stack. So what is stack? Monotonically increasing stack. So we only maintain the order of. So what is monotonical stack? Monotonical stack will be increasing element, like we can keep the stack with all the increasing elements, or you can keep all the decreasing element. In this case, I'm maintaining a monotonically decreasing stack. Suppose if we have a decreasing elements, suppose in that case, like I'll just push the elements. So in the decreasing time, we just popping from the backwards and just initializing the elements, right? Directly putting these elements, right? 3 2 1. This will be the order. Suppose I'll clear this. I'll explain you clearly. Suppose why I'm maintaining monotonically decreasing stack, because as you can see, if I had a monotonically decreasing stack, so the order of elements will be 1 2 3, and I can directly, if it is a decreasing element, I can pop it and put this order. Because when you are popping out of the elements from the stack, it will be in a reversing order. So if you have a decreasing element, the order should be reversed, not in the case of increasing. So I can directly put it. Suppose in other case, if you have a element I, which means you can directly pop the elements until the stack is empty. Suppose I'll give an example. Suppose if you have a increasing. So from I equal to 0 to I less than or equal to n times, what we can do is we can directly push the elements I plus 1, because we don't take the case 0, so we'll start from the 1th element 1 to 9, right? So in that case, so the 1 will be pushed into stack, and the next element is I. So what I told you, if it is a D element, we can directly push into the stack, or else if it is an I element, we can just pop the element and store in, just take an answer as a empty string. So as it next element is an I element, you can pop the element and add it to the string. So I is 1. Then again push the 2 element. So 2 is done. Then again we have an increasing element. So just append the character and just put the 3rd element. Then again increasing element. You just pop it 3 also out of the frame. Then we got a decreasing element, push the 4. Then again we have a decreasing element, push the 5. Then again we have a decreasing element, push the 6. So current stack would be 3, no, 4, 5, and 6. Then we have again I element, what I told you earlier. So if we add a I element, we simply just pop the elements and append into the stack 6, 5, 4, and we'll just remove it, and we have a 7th element, and it is an I, so we can just add into the string. So this will be the resultant string, 3 3 6 7 elements. Yeah, we have a 3 3 6 7 elements. Yeah, so that will be the case. So what is the intuition behind this? We are maintaining a monotonically uh, a decreasing string. So whenever we get a decreasing string, we can directly push it into the stack, or else if we find any increasing string, we can just pop it out from the stack and add it into the answer string, and finally return the string. So I'll just walk you through the code, so you'll get each and every point clear around the question. So let's just jump into the code. So what I'm doing here, we'll just zoom in so that it will be more visible to you. So what I'm doing, I'm just getting the size of the string, and I'm just creating a answer variable, so which can store the string of the smallest possible string of that meets the condition, and we here declared a stack as well. So while iterating through these numbers, we're directly pushing the element I plus 1, because we are not starting from the 0, because we need element which is greater than 1 and less than 9. So as you can see, numbers consist digits 1 to 9 as well. So while, which means like if it is the end element, so suppose we have a case, all this, so there is no I. So when do we pop the elements from the stack? So there is no I, right? So I'll just simply push 1 2 3. So if you don't pop it, and how do we store in the answer variable? So if so what is the condition to be popped from the stack? If we had a pattern of I, if I had a pattern of I, we can just simply pop it of the from the stack. Or even if we reach at the end index, so in this case we don't have any I. So if we reach the index, we simply pop it of the all elements and put and add it to the answer variable. So yeah. So while st0, why are we are using this? Because there may be a case in which that stack is empty. In that case, um, we can we don't get error over here. But generally you don't find a stack empty because we are directly pushing the elements, then we are checking the condition. That's why we don't get any case that says the stack is empty. But just for a generic case, I just put there. And even what are the conditions that I told you earlier? If that current iteration reaches the nth element, which means all the elements have been reached, and still if it is a stack is not empty, in that case we just pop the elements from the stack and store it to the answer. Even if the string of I is if we have an increasing element, then we'll just pop the elements. So how do we pop? We are just, as we know we are storing the elements as a integer. So how do we convert the strings? So we have a 9, simply add the string of 0 plus 9, so it will become a string of 9. So that's what we're doing, just popping the, so I'm just adding the string plus what will be this element. This will be the stack dot top, so that is the string that is present on the top of the stack. So what I'm doing is just adding with the top element and simply popping the element, and then just returning the answer. So just a small piece of code, just little logic. So if we get to know like what is the real intuition, that will be more than enough instead of implementation skills. So let's just run the code and see. Let's just submit the code. Voila, it's submitted. And that's it for today video, guys. So if you like the video, do subscribe to my channel, hit that bell icon so that you never miss any notification from my channel. And that's it for today video, guys. Thank you, tata, bye bye, see you tomorrow, bye bye.